Good afternoon. We'll go ahead and get started. Welcome to our webinar. Today we will be focusing on design accelerators that are contained in Autodesk Inventor. My name is Cherise, and we are glad to have each and every one of you. Based on your time zone, we may be on the front end of your lunch hour or the back end, but nonetheless we're glad you're spending your time with us today. One of our primary focuses is how we disseminate information to our client base, and that is through a venue called Live Lab Learning. Live Lab Learning is Applied Software's way of training our clients once they have made a decision on a particular product. As you will see, there are several different offerings. This is an instructor-led virtual-based training. So what does that really mean? Essentially, we do them in half-day increments. It is live training. The only change to that is that the student and the instructor may not be placed in the same physical location. All things remain the same. The instructor has the ability to look at your screens and to help answer any questions that may come up during the training session. As you can see, we offer extensive training in the Inventor platform, starting with fundamentals, advanced part assembly, and then even update training for those that stay current but do move from version to version. In addition, we also train in Inventor LT. You may get full course description, dates, and prices for this type of learning at livelablearning.com. We do want to make you aware of some upcoming events at which Applied Software will be located. We will be at the Southern Automotive Conference later in this week, so if you are in the Alabama area, you may be in attendance, and if that's the case, certainly look us up at our booth. And then later in the year, we will be at the FabTech Conference being held here in Atlanta. For any detailed information on either one of these events, or if you have questions concerning Live Lab Learning, you may reach out to Marcia Tucker. You see her phone number and her email address there on the screen. Before we get started, we want to encourage you to ask questions. You may type them in on the bottom right-hand box. We will be paying close attention to those and answering them as they come in, or if necessary, we may wait until the end of the webinar. Today we will primarily focus on a few of the design accelerators contained in Inventor. With 20 available, it would be impossible to cover them all in this short time frame. As a result, Dennis will focus primarily on shafts, spur gears, and roller chains. With that being said, Dennis, I'll turn it over to you.
Thank you, Cherise. Hi, folks. All right, let me get things opened up here a little bit, and now y'all should be seeing my Inventor screen at this point. So sit back, hope you've got your sweet tea and popcorn ready, and enjoy the show. What we're going to be looking at, I'm going to start off first kind of working inside of the Design Accelerator environment. As Cherise mentioned, there's over 20 different areas of the Design Accelerators and they're actually reached, this is confusing to a lot of folks, but you've got to be in the assembly environment first. And so when you click in up here, you'll see basically on the Design tab, all of these are the various design accelerators that are available. So they range from generating shafts, different types of gears, different bearings, roller chains, V-belts, on and on it goes. And so you've got various things here that will help speed up your design process. Now, some of them are working very heavily with the Content Center and just pulling things directly out of the Content Center. Some of them are actually building components as you go on the fly. So in some cases you'll see the Design Center coming up and being utilized very heavily for the particular object that it might be placing in. Other times you're going to actually see geometry being drawn up on the screen all nice and new and fresh. Now, if any of you have gone into the help of Inventor and maybe downloaded some of the tutorials, you might recognize this reducing gear box here that has been actually as a part of that tutorial system. I'm going to focus in on it. If you've gone through those tutorials, you'll see a little bit that you've probably already done with the tutorials, but I'm planning on just using this as kind of a model to start with and talk about things and go into a little bit more detail. Now, what we're going to focus on is this shaft here, and we've got a couple of bearings in place here. We're going to be focusing in on these. Now, want to show you how this gets started, how you can get rolling by in the use of these design accelerators. So what I'm going to do to accommodate that for right now, I wanted to kind of show you first off where we're heading. And so I'm going to suppress these real quick and as well suppress the shaft so that we can take a look at things and how you might approach it from scratch. You always end up starting somewhere. In this case, I'm going ahead and starting with the housing. But at times you might actually find yourself starting with the bearings first and build the housing around it. So sometimes the order in which you're working does not necessarily mean that you don't get to use the design accelerators. But having to start somewhere, I'm starting here with the housing. And up here in the middle area, we're going to be seem to be getting a lot of feedback from somewhere. Somebody will mute their, thank you. All right, so first we're going to be looking at the bearing area up here. So I'm going to click on bearing. Now, this interface, the way this works to help you speed up your design process, get quick access into the content center instead of having to go through the library itself and try to find the part. This is much like a search method. And so you've got some input areas up here in the upper right of the dialog box, and then from that we'll be able to hit the little update button down here to give us a list of available bearings that meet our criteria. Now also up here you'll see right now it's defaulted to just regular contact ball bearings, but if you click the down arrow here, you can click in and go to any of the categories of bearings that are within the content center. All right, now at this point what we have to start doing is kind of giving the design accelerator a little bit to work with. And so I could actually type in values up here and make choices from values, type them in that I wanted for my outside diameter. And it's maybe a little hard to see up on your screen, but I've got a little icon here, and basically the top section here has to do with the outside. The middle section is the inside diameter of the bearing, and then this is the width of the bearing, and so it corresponds with our icon here. So first thing I'm going to select is a cylindrical face. And if you look down here now where I'm pointing over into the housing, I'm picking this scooped out arc here to represent the outside diameter of my bearing. And when I click on it, it immediately starts to give me a little bit of a preview here of the bearing and the shape it's going to take out. Now, if you look up here in the interface right now, it's already saying 37 millimeters in this case. And so it's grabbed that information directly from the model and says, okay, I'll feed it in there. Now, you'll notice, too, it's grayed out. I can't change it. Since I've selected existing geometry, it's associated to that geometry, so it's not going to let me change it. Now, if I already had a shaft in mind that I might want to design from, or I was going to utilize something off the shelf, I could put in the interior diameter here, or I could give it even a range to go from. So I could say, maybe from 15 millimeter to 25 millimeter. And so the first section here is from the smallest size, and then to the right is to the largest size. If I let that sit there on my cursor a little bit, you'll even get the little help that comes up. You do have an option here to do a measurement as well. Like I said, if I had a measurement that I could choose from, I could pick that directly from the geometry. The final area that we're going to be looking into here is, again, I could do a measure and say, well, I want it to fill up maybe this gap. So what I'm going to do is pick on the edge there. That gives me an 18. Now the 18 is on the low side. All right, so I'm going to put it in over here on the high side. And then on my low side, I might give myself a range now to choose from, and I'll drop that down to like 9 millimeter. I could drop it down to 7 millimeter, etc. Now, once I've done that, based on my selection up here where it says angle contact ball bearings, I can hit the little lightning bolt here to update. And now it gives me a list of only those bearings that I've got within my content center now that meet the criteria of my highs and lows values that I've got listed up here in my Design Accelerator. Now with this then, I can look down the list, decide which one I might want to choose from. I'll just grab the first one for this. And I'll say OK at this point, and we'll pop it into place. And I made a little bit of a mistake here. One thing I forgot to do is tell it exactly where I wanted it to end up. Well, that's not a problem. All I have to do is reselect it, right-click, and say Edit using the Design Accelerator, and basically get my cylinder face again and my start plane that I wanted. Now here again, if you're familiar with Inventor, sometimes it says start plane. It says, well, what do you mean? And you'll notice here I can just flip it over, flip it back and forth until it gets into the location that I'm after. Then I can say OK, and that pretty much locks it in place. Now at this point, it is associated to the part and to the housing here, and so it is locked down. It will not move. It spins, but it will not move out of that location. I can again right-click on it. Maybe this time instead I might want to change its style a little bit. I could go down to, for instance, a taper rolling, give myself a selection here. It remembers all the settings here, if you'll notice. Now this is one thing I've noticed. Sometimes I've actually got to type a value in again to get the little lightning bolt to come up. So if I try it again, see, it came up available then. So sometimes it just needs you to type in there a little bit. Maybe that's a little bug or something, but again, I've just noticed at times I do need to type something in just to wake up the lightning bolt, even if I type in the exact same value. I can once again, based on the tapered roller bearings, I can hit, give me my selection here, it resorts it based on that, and then I'll come back down here and, for instance, find the DIN style that I might want to use. Once again, say OK, and it pops that one into place. Now, another, of course, thing that we always like to do, I always like to put a little color up there. So let me grab a color to go by here now. So I'm just going to make that a cyan color, kind of help it pop out on the screen. Now, another case for using the Design Accelerator is, you'll remember what I said, that it locks this particular bearing now in place. If I just mirror it over into place over the other side, it's not necessarily tied down at that point. It's not necessarily locked down. And so again, I might could copy it over or mirror it over and then tie it down myself, or I could just real quickly, once again, I'll change a few of my settings here up front this time. Go back down to the tapered bearings, and then my cylindrical face. Again, the start plane, which is one choice I always seem to find myself forgetting sometimes. Get down here and get the start plane selected. There we go. And then I'll flip it over into place. And once again, I know some of these values here, so I think I want that to be about a 20 on the inside. Hit my update. And let's see, what did I do wrong here? 12, 20, 25, update again. There it is. And I had to get all my values in place, and so there's my DIN 720 again. I'll just click on it and then say OK, and it puts it into place. Once again, it's locked in place. So again, I could have mirrored it over, but in this case, I just reutilized my Design Accelerator to get it popped into place and apply the constraints to it immediately. And so now we've got our two bearings in place. Let's take a look now at our shaft generation. Now, shaft generation can be approached a couple of different ways. Again, you could come up, first thing you do, you hit your shaft. Now, I'm going to reset the settings. This will reset all my values. This might be how the shaft will actually look when you first place it with its basic settings here. Because of the way I came about it here, you'll see there's the shaft over here in the picture as well. You can actually see the updates as you change things in the generator here, the Design Accelerator, on the shaft that you've got over, that you may have placed over in the picture, or in the little preview down here in this area as well on our dialog box. Now, by default, I've got it set here. I went back to the default settings, so this might be how it'll look the first time to you as well. And so it's got some various settings on here to kind of give you an idea of what you can start with. Now, this is a case where I'm going to show you a little bit about how you can use, again, your existing geometry that you've got up on the screen, your existing components, to help you at least begin to possibly get the shaft into play into a way that you might want it to look directly from the geometry that you've got up on the screen. Now, to understand this a little bit, we'll come back down into certain areas, but primarily if we're working in our sections area, so we're working at, in a sense, piece by piece. So each if you call it cylinder in this view here, even this cone shape, is considered a section of the overall shaft. Now, with the first cylinder section here, as I come up and pick on it, you see it highlights it in blue. Again, if you're looking on your screen, you will actually see the preview of which section you're working on down in the lower section of the dialog box. As well, it is highlighted over in our model view as well. And I'm not focused so much on the model view as much as I am on the preview in my dialog box. Now, also a couple of other things to be aware of with these dialog boxes. Anytime you see these little chevrons, little less than arrows or greater than arrows, if you click on them, it opens up more information. So see here, again, in and out, roll it down, roll it up, and so you get different things showing up depending on what you're picking. There is a calculations tab which allows you to look at the shaft that you've built and make sure it meets your design criteria, and you can know where the loads are and how the loads are going to affect your particular model. Now, into the shape here that we're particularly after, if I come to the cylinder section here where it's got the values, the 50 by 100 is the default. If I double click on it, I've got the option here on the diameter to hit a little arrow and say measure. And this is where I could select the inside of my bearing here to get that value of the existing bearing. So see, it's updated it to a 20 millimeter diameter. Same capability with my length value. I could come in here, maybe pick along this edge here to get the length. And as we say OK, you see that has updated in our dialog preview, and might be a little bit harder to see, but it's actually updated over here on our model that's placed out. I'm going to move that here in a second and get it out where we can see it a little bit better. So there, I've been able to use some existing geometry to represent what I'm actually after here. Now, as we move along in the process, I can come down to the next cylinder, kind of do the same process here, where I could say, okay, I want an outside diameter, maybe this time use my outside of bearings, and so I can select that, and then again my length value with my measure. Here, I'm going to try to select very carefully a point to a point. So here again, I'm looking very specifically at what my cursor is highlighting. In this case, it's just a little tiny yellow 0, a vertex point. And so with that, that has updated my length value, and you see our picture has updated accordingly. Now, our next step would be to come down to the cone level. Now, to change it from a cone, that's as I open up or hit a particular section, I get different value options here that I can put in. And right here in this kind of left center is a little down arrow, and that's where I can change this into a cylinder, a cone, or some sort of polygonal shape. Okay, so I have some different options there for this particular section, and in my case here, I'm going to change it to a cylinder. It's saying, hey, you're making a big change to it, and that's fine with me. I'm going to go with it, and so I've changed that to my cylinder now. And this here again, I'm going to double click on it, come up here to my diameter value, and I'm going to measure again the inside of my bearing over on the far side at this point. And once again, I'm going to do a measure of the length, and I'm just going to grab that edge there and say I want it to extend out the length of that edge. And so now you can see this is starting to take some shape. My final cylinder here, I'm just going to hit, there's a little X right here. I can say just get rid of that one. And so at this point now we've got some we've built maybe our existing or our first pass at the shaft. We've built it based on the geometry that is sitting there looking at us. Now in regard to this, we've also had some features that were kind of left over from the original setup that are available there for us to work with as well. And some of them maybe I don't even want. You'll see we've got out here in our picture is kind of an inside radius of a fillet going from our first cylinder to our second cylinder. If I decide I don't want that, I can go to that radius value, click the little down arrow beside it and say I don't want to feature at all. I've also got a fillet on the first edge, and if I click on that, there's my value for it. So it's a ½ millimeter offset, and then it does a 45-degree angle. Maybe I want that to be a little bit more, so all I have to do is type in 1 millimeter, check that box. And here again on this one, we might want that fillet. You may not. I could say no feature, take it completely off. And then our final feature down here, we could add a fillet to it if we wanted to. But at this point, I'm just going to say OK. Let it build the shaft as I've got it designed. And so I'm going to place it right over here so that we can see it. So very quickly I went in there and I got a shaft built. Now, once again, it's not exactly the shaft that you may have remember us looking at earlier. If I come back over here to that shaft and unsuppress it, you can see this is how the finished shaft ended up. So let's take a look at how we could now take what we've started with and start modifying it to meet the more of the design standards that we might be after. Now, I don't have these values saved in my mind, y'all. A lot of times with shafts, you've already got maybe over in the AutoCAD side, you've got cross sections of them with certain values already there that you might be working with. You might have some standards that you're using out of the catalog. I'll admit I've cheated a little bit, and I used Inventor to actually document that shaft a little bit to give me some of the values that I wanted. But we'll take those values now, and I'll take these values here and show you how we can begin to go through and refine the shaft design based off of the one that we've got existing already built. So to do that, we select the shaft, right-click, and there's our Edit Using the Design Accelerator. And we'll click this back up, and now we're right back in here. Now, a couple of things that I'm looking at here is that we had kind of a stair step coming up to our bigger opening that or bigger section here. So I could look at it from a point of view of actually adding other cylinders in. And so whichever one you have highlighted up here. Now here this time I'm going to come over here and pan so you can kind of see it a little bit better. With this one highlighted, I'm also getting a highlight over in my model view as well as the image that's in the dialog box. If I decide I want to place another cylinder, I can just hit Insert Cylinder, and it takes the cylinder that we just had highlighted and just duplicates it. So now I've got two different cylinders. Now it doesn't necessarily take the features that were there. As you can notice, the chamfer didn't come down. but the cylinder definition itself came down with it. And so we've got two of them the exact same size. Now here again, I might want to refine the initial cylinder a little bit. Very simple to do. I can come in here, say maybe instead of 18 millimeters in length, I might take that into a 15 millimeter in length. Of course, it's shortened it up here in both sections, and then I can go to my second one, and then once again, I will change the diameter. I'm going to stair step up a little bit in my diameter size, and then I'm going to take the value down to a 7 millimeter. And here once again, if I want a second or a third stair step, I can hit cylinder again, and it picks up where the other one left off at the 26.7. So I'll double click on that, pick it up. I'll make this one a 32, and its length at 9 millimeter. Okay, so again, I'm starting to refine this design a little bit more. Now, as I move along, I generally like to go through and get the cylinder parts done, and then I will come back and I will add in more refinement to the design by adding more fillets, more tapers, more chamfers, and we'll even put in a couple of retaining rings. So the next, I've got my stair stepping going. I'm going to go to my big cylinder now, the big long one here, the big diameter, and I'm going to increase the diameter a little bit. So I'm going to take it from 37 to 63. And then my length, overall length is only going to this time only be about 30. So I've kind of doubled one value and shrunk down the other value. Now the concept with this particular shaft is that we're going to add the gearing to it as a feature. So this larger body that we just put on, could maybe we needed to keep that if you had a gear that was going to be slipping onto it, maybe using a key of some sort to hold it in place, then you may have kept the smaller diameter value. In this case, I'm kind of planning ahead here to have that as part of the gear teething added to it as part of the feature of this particular shaft. I'll say OK to that. You'll notice it's starting to update here down in the preview of our dialog box as well as over here in our model. Now there's also red dots over here. You'll kind of notice as I kind of just change and put my cursor on it, it says I can actually drag values as well over here, and they'll update in the dialog box. I can drag placement just by grabbing these arrows and the dot locations if I wanted to just kind of visually get something in place that I didn't know exactly what the value was yet. So again, some either free-floating sizing ways of putting the features in there, or more specific by doing it over here in the dialog box. So once I've got that cylinder set like I want, I'm going to stair step back down, starting with this cylinder, where I'm going to drop this one down back its diameter to 26, and then with the 19 length there, I'm going to change that to 16. We'll say OK, and then once again I'm going to add one more cylinder, and it picks up again like I said before at the last value. And at this time, I will drop this one down to 20, and its overall length is going to end up being 65 millimeters. So we'll say OK, and so now it's really starting to take the shape that I'm after. Now I'll say OK to this so we can just kind of see how it updates and comes all into place now, so you can see the shaft is starting to take shape. And at this point too, I think I'll go ahead and put it in place. And in that case, all you have to do is your standard constraints. And so in this case, I'll do an insert style constraint. I'm going to grab my end here, and I'm going to pop that into my cylinder or my bearing over here on the far side. Got the distinctive little pop sound in my case over here when it pops into place, and I'll like it. I'll look at that. Of course, this is always nice. Half the time when I do these things, I always end up having to flip it over, but in this case it came in just nicely, and I'll say OK. Now, it is in place. It's hard to see right now, but it is rolling. So it is spinning in place. It's an insert, so all of that's looking good, and I'm just kind of eyeballing it here saying, yeah, it looks like I got that aligned very nicely as well. So let's add a few more things, features to our shaft here. I'm going to select it again, right-click, edit using the Design Accelerator. Now, our next feature that we might want to add down on our two ends is a retaining clip. Now, this is a case, again, where the retaining clips must be in our Content Center, obviously, for us to be able to choose from. And to add a retaining clip, you come to this fourth box. So the first box is you can add certain features like chamfers, Phillips, threads, etc. The center or left of center is the shape of the overall section. In this case, we've been using pretty much cylinders. The next one, or center right, is the end condition for the other side. Notice you can have reliefs as well. And the fourth box is for adding particular features to that particular section. So in this case, I want to use my Design Accelerator to add a retaining ring. Now, it pops in, kind of goes to a default retaining ring. If you look closely over here to the right, there's kind of one of those three dotted buttons that you can click, or you can just double click on it, either one, and it brings up now, and we're starting to get into what is available over in our Content Center. Now, it kind of defaulted to this ANSI B27 value here. I like the DIN, so I'm going to grab the DIN. Notice that it already knows the size. All of that came directly from the Content Center. So it understands the size based on the diameter of the cylinder that we're on. It understands the length of the particular section that we're working on. So these two values you would probably never find yourself changing. The X distance, though, you might need some sort of idea of a change on it. Now, in this case, I can do my measure again. There's my measure, but it's saying right now measure from the front edge or the first edge, so it's actually measuring from the edge that's sticking out here. In my case, I might want to measure from the other side so that I can measure a face-to-face based off of the width of the of our bearing here. So what I'm going to do now is come in here, and hopefully I can click the distance here from, I think that looks good, from that edge. Whoops, missed it. I want to just get the edge there, not the, I think if I go from right there, I'm going to let it sit a moment so that it hopefully comes up and picks the face to edge. There we go. So I picked from the face to the edge, and you can begin to see the preview here is showing me where that retaining groove is going to be cut out of the cylinder. I'll say OK at this point, and just to give you an idea here, well, I'll go ahead and just say OK all the way out. And so now you can see it's gone ahead based on the retaining clip that we're going to be using or setting this up to be designed for. It's put it in the depth it needs to come into as well as the width. Now we'll go over to the other side real quick. I'm going to select right here, right click, edit using the Design Accelerator. And again, I can select the cylinder section that I want to work on directly from the 3D model over in our design area, or we can actually pick it from here in the preview down at in the dialog box, or of course if you know which one it is, you can come up and pick it up from there. Once again, I'll add another retaining ring. Once again, go into my three dots and pick the one that I want to use. And it always likes to default back to first edge. I did it by the second edge by changing it. In this case, it's defaulted back to the first edge. And here again, I'll do my measure. So I'll scroll around here. I'll try to grab the appropriate edge. I think that's right. Whoops. And then okay. There's always a little bit of a trick here with this one. Got to get it in just right. There we go. And then this space here, for instance, and there we go. We got it in place. And so you can see even with the preview, it's starting to place it. I'll say OK. Now with this, while I've already still in the Design Accelerator, I'm going to add a few other features. I know it'll put that retaining ring in now. So I'm going to come back over. I think I'd like a strengthening fillet on this inside edge here. So here again, what I can do is select the cylinder that I want the fillet added to. Okay, so it's actually the smaller, not the larger. And then I can come into the front side and say I want to, actually on the end of it, I want the fillet added. And in this case, I'll make it a 3 millimeter radius. You can begin to see the preview coming into play. And I think I'll end up doing the same thing over on the other side. So I'll select the cylinder that I want it to add to. And again, the fillet. And again, the 3. I'll check the box. I can see my preview down here in the dialog. I can see the preview over in the 3D model. I'm going to add a couple of fillets on my big center cylinder area. So I think I'll do a chamfer. And so here again, I'll do a 1.5 millimeter offset at a 45 on both sides. Okay, again, I can see the preview starting to happen. And I'll say, okay, let it build it all up real quick. And again, I can see very nicely my fillets in place now, my retaining rings in place. Okay, fillets, chamfers. Okay, let's come back now to this, our final piece here, the last cylinder that we added. I got a couple of more things I want to add to it. I want to put a key on it, a key slot on it as well. Now, let's go ahead and finish off this edge here and put a fillet on it as well. So I could come in here, or a chamfer on it as well. And again, this time I'll just do a 1 millimeter instead of a 1.5 millimeters. Let's check it, see my preview. And then I'll add the feature of a keyway groove. Now here again, it likes to default to certain ones. And in my case, I always like to go to the DIN, so I'm going to use the DIN there. And as I rotate this around, you'll see that it has already placed it in a kind of a given area. As far as its length, I could grab those arrows. Remember, I could come in here and actually grab arrows if I wanted to. In this case, I'm going to pick from the values over here in my dialog box. So I'm going to give it a 22 length. And my offset, again, I could do it from the first edge or the front edge. Just is up to me in my design process which one makes better sense to me. I'll make this about 36 1/8 of a millimeter. And we'll say OK. So it's shifted it up now. And at this point now, I can say OK. And I've pretty much got my my shaft finished out now using the Design Accelerator. Now, once again, let's get some color up on the screen. So I'm going to go up here and make it a little bit brighter red so that we can see it nicely. So there we're contrasted with our blue and our gray backgrounds. All right, so at this point now we've got the shaft generator we've used to actually generate our shaft. And now we're going to look at the gear, creating the gears based off of the shafts. Now, when we come back to our Design Accelerator, we've got the spur gears, the warp gears, and the bevel gears. And this we're going to real quickly look at the spur gears. And at this point, keep in mind that what I was thinking with this shaft and the way that I built it is that this is, we're going to actually add the gear teeth to it as a feature, while we're going to have a gear over on this other shaft, our shaft to the far or to the right side. You'll see it's got a keyway in it to lock maybe a gear that you, again, would take off the shelf and just slide onto it in the assembly process and then lock it in place with a key. So we're going to start our spur gear generator. And in this case, once again, this dialog box can be a little bit overwhelming. Again, you can kind of say, well, I'm going to simplify this dialog box by hitting those little chevrons to make it smaller, make it larger, open. plus you do have a calculation side that once you hit calculate, it will look at what you have set up as far as your design to make sure it meets your design criteria. And you'll get a little bit of a feedback down here in this blue area telling you that, yeah, calculations indicate that it would meet your compliance. Now, in this dialog box, as far as your initial setup, probably the best way to start if you were playing with this would be just to go to Module. Module allows you to set certain values while keeping other values, in a sense, grayed out or locked down so that you can't change them. So if we go to Module, you'll notice one thing here is the gear ratio. Now that comes down here into the bottom on whether or not do you want to define a gear ratio to follow or the number of teeth that you're going to follow. So again, it's kind of, which way do you want to go? You've got some options here on how to set it up and how to design it. A couple of other settings to point out is the pressure angle as well as a helix angle. I'm going to do a 12-degree helix angle, let you see that, and then show you how you can straighten it right back up so that you can play with it both ways to see what might best meet your design standards. Now, in this section here, the Gear 1 and the Gear 2, it gets real important on how you set these up. As a feature, which is what I've got selected here, it's going to add it to the shaft, and in this case then the shaft and the gearing will become one item. Gear 2 I'm going to do as a component, so it would be representative of a gear that you would maybe take off the shelf, slide onto the shaft as an assembly, lock it in place with a key, and then there you go, you've got it. So what I'm going to do is you do work on this directly onto your model now at this point. And for Gear 1, you say select the cylindrical face that you want it to follow, and then start playing, okay? And so you just select the edge there or the side. Now, again, might be a little hard to see, but you've got some beginning line work being laid across the flat surface of our shaft here. Now, a few things that I can type in is the number of teeth that I might want. Here again, if I was more inclined with just gear ratios, the number of teeth might actually be grayed out. But here in this case, I've got a better feel for the teeth value, so I'm going to put in a 29 and a number of teeth on the opposite side of 57. The face width corresponds to the width here that you want, how wide you want this gear to be. Now, on my component 2, again, same process, cylindrical face, and then the starting plane face. And at this point now, we're starting to get a little bit of a preview of how this is going to mesh together. Now, you have some unit corrections here for a little bit of tolerance that you can put into play. As well, again, you want to keep in mind your pressure angles and your helix values. Once you've got your settings set pretty much the way you want, you do want to hit your calculate button. You might actually see your preview update a little bit, but then once you say OK, it brings them in and it places them. Kind of thinks a moment here. And there we go. Now we can see the two gears have been brought in together. Now, if you look over in the model browser, you'll see that it is treated as an assembly. So these things are being stored out as individual parts. So here, once again, when you hit save, you'll notice you got a lot of first-time initial saves going on here. So I'm going to go ahead and say yes here in case I have a crash. I can get back to where we are real quick. Now, a few other things here as far as getting these to line up. When, as you can see, I can move one gear, doesn't necessarily move the other one. Okay, so at this point, even though they were generated together, they're not exactly tied together at this point. What I'm going to do is suppress the housing so that we can see a little bit better. And what I'm going to do is position this just slightly, like so. Okay, just to kind of make it look like it's fairly clear to me, just visually looking. I'm going to actually go to this gear as well real quick, y'all, and put a different color on it so that y'all can see this a little better. That gray's getting kind of lost in there. I'm going to go down and how about a smooth yellow? There we go. So maybe y'all can see that contrast in there a little bit. So what we can do is, again, going back to our regular assembly constraints, I'm going to put a motion constraint in here, but this ratio value I can grab directly from the Design Accelerator. So I'll come in here and say edit the Design Accelerator. Here's what my gear value came out to be, a little bit over 1.9. So I'm just doing a Control-C, standard old Windows copy there. I'll do my constraint now, a motion, set my different values right. I'll go ahead and put the ratio in. Now, the main thing is your first selection that you select the big one first. So I'm going to select that shape in there, and then I'll select my second gear. And we'll say OK. And at this point now, you can see as I grab the big one and spin it, it turns the gear and it looks pretty good. Now, a couple of other things on the Design Accelerator, just to show you this as well. You do have previews that you can look at. That particularly what's nice about the previews is that you'll notice that the teeth meshing on the previews is a little bit more real world as to the way these teeth are going to actually end up looking. Okay, you actually got it from a few different points of view with your gear racks and all for the cutting methods, and also again just some different ways that it's actually going to give you a preview here of the way your particular gears for gear 1 and gear 2 are going to mesh together. But the main other thing here is, I'll kind of rotate this around so that you can see it, is that the teeth that you have here is a representation of the teeth. It's not exactly exact, okay? And they do that for a reason, is because this could end up being a lot of geometry cut here that could actually be detrimental to the performance of the program. So they've given us another step for documentation where you can select the gears, right-click, and export the tooth shape out to a separate model. And so once it comes out here, and you can kind of see that tooth shape has been developed a little bit more now, and notice how many different segments there are as it comes down. All of them are locked to keep it from being changed from the original model that it was generated from. And of course, at this point now, I could select it as a cut with my distance going all the way through. Now, if you wanted this to be your helix style where it's shaped, you actually have to take the profile and duplicate it on the other side and then move it the 12 degrees, and then you'd be able to do it as a loft cut. Here I'm just doing it as a straight cut. So I'll say OK to that. I've got my straight cut now. And then again, my circular pattern here I can use to select the feature. And then my rotation is just the center of my pieces here. And then I put in, I know that was a 57 teeth all the way around. And was it 57? I thought it was 57. Oh, that's because I understand now. It's because of the way way it was generated. So whoops, did that one a little bit bad. Let me go back. And the reason we had a bit of a problem there is because of this one was set up for the different type of cut. So if I say edit using the Design Accelerator and take the helix angle out and then say OK, and we'll let it update, now that cut will do a little bit better. Export the shape. Oh, I think I probably forgot to select the gear too there when I did that. Anyway, OK, just to show you this real quick. And then there is the tooth development. And so I'll do my extrude cut all the way through. And this time, when I do my circular of that feature with 57, yeah, that looks better. Say OK, and that cuts it out with a little bit more of the smoother shape going all the way around. So that would be the actual gear then that I would want to actually document. Now, that goes along with the gearing concept here a little bit. One other area, y'all bear with me, I want to show y'all real quickly. This won't take long. I've actually got this set up a little bit. This is our roller, chain roller. So I'm going to go back into my Design Accelerator. When you've got where your shafts or your posts are going to be, that's going to be where you need to mount your gears for a chain-driven assembly. The roller chains actually works a lot in your favor at this point. And just to quickly show you this, of course, you pick from the different chain links that you might be wanting to use, and you've got different ones and different links and things like that directly that you can use from. Number of chain links is kind of arbitrary at this point. And what you're going to select first is a plane to associate this chain to. And so I've got the center plane of my initial pin there that I'm going to associate it to. And then I've got various places where I can locate my sprocket or gear by fixed position on those pieces. And so you can see that dropped it directly in. I can do the same thing now with the second one and lock it into my other pin that I've got there. And then we'll say, okay. Now you always get this message whenever you say, okay. What it's saying is that, wait a minute, based on the way you originally put this in, you've made some changes. Just say accept, and it develops it and it builds it for you over here on in your model. Now you can always come back, select on it, say edit to using the Design Accelerator. Much again, like I showed y'all earlier, these little dots will allow you to stretch it open. It will stretch it open based on what is capable with the number of teeth that can be added or changed. So you'll notice here, by making the diameter larger, it went to a 260 chain links, or as I pull it back down, it goes to 242. So it understands that as you do this, it will make it bigger, make it smaller. I can even say, for instance, OK to this, and again, there's that little message. If I come in here and grab the pin itself, okay, let me let this update. There we go. If I grab that pin and say, well, I need it right there, so maybe I have that tied onto a board in the back or a housing on the back, and say, well, we've got to move this in now. I can now, if you look over here at the design or the model browser, you see you've got that little red lightning bolt, which lets you know that, hey, something's changed. All you have to do is come over here and say, okay, edit it, and it'll update it and move it into place. Now, adding is very simple too. I can grab this pin, let's say I'll move it down into this location. Once again, right click and say edit the Design Accelerator. I'll add a sprocket real quick. Okay, and then the placement is going to be a fixed position on that pin, and then you can roll it under, roll it up. Now it looks like might overlap on itself, but most of the time it'll straighten that back out, but I'm kind of thinking of this as a tensioning, and so we'll put some tension on it by rolling it down. We'll say okay, again saying, hey, wait a minute, you made some changes that doesn't quite correspond, so it has to rebuild it, and there we go. So that's real quickly doing the gears and the chaining. So at this point, finishing up, if I was trying to keep an eye over here on the questioning, so let me real quickly kind of look back over here on the questions. I've got to pull my box out here so I can read these a little bit. All right. All right. Any thoughts on adding tolerances to the shaft? Again, in the shaft generator, as far as your tolerances go, that's more so in your settings of your calculations on what is going to be available and based on the design. But as far as saying, okay, give or take, 5/1000ths of an inch or something to that effect, that would be something you could add in the dimensioning, but adding it here into the model, no, it's looking for something exact. It's like system like vault. Okay, as far as let me read this question a little bit better. Okay, as far as my understanding goes, if you can actually go and open up when you do the save. You can, for instance, well, let me not so much here. You can let me go back and open up my other file real quick. Not just see, it does create these shafts as like little assemblies. And each one of these, I think it will work down the hierarchy. So if we go in, say, and create a particular shaft assembly, it still recognizes it and should bring it into Inventor. Now, I have not actually done that in real life, but again, since it's recognized as part of an assembly, it would grab anything that's associated with that assembly, which would be the parts themselves, and should bring those into Inventor as well. Now, that is something that I can check into and be careful, to make sure that I understand the question, to make sure that it does cover that and does grab that. But I don't see why it wouldn't. I don't see a reason for it not to. Okay, why did I not cover calculations as deeply? Maybe on the tab generator, and as you can notice, you see we're already at the time, and so it's primarily for timing, for time considerations. Next time, okay. Next time we do this, I will look at that as far as doing it more on the calculation side and less time on the design side. I'll take that under consideration and plan a webinar accordingly. If there's any other questions, feel free to type them in. Okay, one thing on the naming there, you do have that option. I was just letting Inventor name it, but you do have the options to change those names. There is a setting that you can hit that will prompt you for the names. I don't know if you've ever used, for instance, like the frame generator. You can set it up that as you create the parts, it will just automatically name them, or you can have it set for you to name them yourself. Again, I don't have the concern, for instance, that you're expressing there about the way Vault handles it, because of the way the Vault indexes things and actually puts a unique identifier on them. So again, I can give that a try and get back with you, Cody, and let you know with my experiments to see if I can freak Inventor out at all. I mean, Vault out at all, but again, I don't see that there would be I don't see that there would be a problem there. But I will check into that to be sure.
All right. With 1 minute over, we'll go ahead and close out the webinar. Thank you so much for spending the time with us today. Be on the lookout for future webinars. We do these monthly, so there are always things of interest to different folks, and we want to highly encourage you to take advantage of this. Also want to encourage you, Live Lab Learning is an area of availability where you can take different classes, and also want to mention that we also provide one-on-one coaching and mentoring through the Live Lab Learning model or venue. And so if you're interested in doing that, we can make that available to you as well. This particular webinar will be posted on our YouTube channel. There you see the URL for that. So if you would like to pass it along or recommend that someone else in your organization listen to it, feel free to do so. Without further ado, we'll close this out and hope to see you again in our next webinar. Thank you.